Hello, and welcome back to the Python Basics tutorial. In the previous video, I covered the many types of operators and the order in which operators precede one another. In this video, I will be covering data collections. Here you can see I have a list of data collections: lists, tuples, dictionaries, and sets. But there's also one type of data collection that is not included here, and that is strings. And strings is a data collection because it is data that consists of characters. But let's talk about lists. So what is a list? Lists are created with square brackets, and lists are actually the most common type of data collection that you will often find within Python programs. So here I say print my empty list and print the type of my empty list. So what this should return is just the square brackets and the class of list, which indeed it does. I have square brackets and class list. But we can also create it using the list constructor. So if we just have the list constructor here, we can also create just two square brackets and a class list. But let's try to add some things in here. So we can define our list. We can initialize it with three different strings. And when we print it out, you'll see that we have exactly what we put into our variable. We can also put integers in lists. Lists do not have any limitations of what kinds of data types can be put in them. So here, if we print it, you can see we have 1 to 9. So we can put in, integers. We can put in floats, complex numbers. We can put in strings, Boolean values, and even other lists. So if we try to print this all out, you can see that we have all of what we put in here. So there's no limit to what kind of data we can put into a list. And then we can do the same thing, but with a list constructor. If we have a list, such as this one, of different kinds of fish, what we can do is we can assign a variable with a list constructor to that variable. And what will happen is we will have my new list, which has carp, brass, salmon, and red snapper. What's interesting is that they are not the same because what happens is my new list takes a copy of my fish list. So these are not the same lists, even though they contain the same values. And then we can also use the length function. In the previous video, you may have remembered that we can use the length function to calculate the length of strings. But in here, we can do the same thing with lists. So this actually checks not how many characters we have, but how many values in our list do we have. So in this case, it would be 1, 2, 3, 4, which indeed it is 4. And then we have list indexing. So what we can do is, instead of just saying, I want to print the length, I want to get a specific value from this list. So here we have 0, which would return red snapper, 1, which would return carp, 2, which would return bass, and much like strings, lists can use negative indexes. So -2 would be carp, because bass starts at -1. So it should return red snapper, carp, bass, carp, which it does. Red snapper, carp, bass, carp. And we can also grab sections. And I've also included a list value within this list to show how we can grab, for instance, the letter A. But first, let's just take a look at what we got here. So print my first variable, 2 to 4. So that would include 2 at index 2, and it would not include 4. So the values we would get for the first one is 3 and 4. And then for the second line, we have everything to 4, which means we would include 0, 1, and 2, and 3, but we would not include 4. So we would just get 1, 2, 3, 4. And then we had -3 to the end, which means this would be -1, -2, -3. We include -3, which means that for this line we would receive 4, 5, and then this list of A, B, and C. If we do -4 to -2, then we would have -1, -2, -3, -4, which means we would have 3, to 3, 4, 5, because it would be -3 to -4 to -2. So we'd have 3, 4, 5 for this line. And then here, you'll notice that we have actually two different indexes. So in the case of which grabbing a value with this index returns a data collection, we can use another square brackets to once again get the index. So we're getting the index of the index in this case. When we grab the value 5, we have A, B, C, and then let's say that we just want to get, B and C from this case. This index would also begin at 0, 1, and 2. So when we grab the values of 1 and 2 within the index 5, we get B and C. And then we can also use -1 because it's still at the end of the statement, and then we can just grab all the values, which should return A, B, and C. Which indeed it does. You can see 3, 4, 1, 2, 3, 4, 4, 5 in the list, and then we have 3, 4 once again, then we have B, and then A, B, and C. Then we have the sorted function. So let's say that we have a list, but it's unordered and it's very chaotic and random. We just have a bunch of values that are not ordered in any way. What we can use this sorted function, which will sort them from least to greatest. What we can also do, however, is we can say reverse is equal to true. Now what happens here is that it will actually sort it from greatest to least. So you can use this to sort of order your lists any way you wish. You can also check to see if an item is in a list by using fly in. We can use this in operator that we learned about in the last video to try and see if a string exists within a list. And you can also do this with integers, but this should return a true value, which it does. But what if we wanted to change the values in a list? You remember that, and strings are immutable, so unfortunately you can't change values within a string. But lists you can. So here I have my second list, which is carp, brass, fly, and spider. But I want to change carp to harp. So what I can do is in my second list, I grab the 0th value, the index, which would be carp, and I replace it with harp. And then I say, okay, I want the values between and the index of 2 to 3 to be equal to red snapper and shark. So 0, 1, 2, so fly would be replaced with red snapper, and then 3 would be 2 to 3, which actually would be only the second index because 3 is not included, which means what you would really get here is harp, brass, and then a list instead of fly where you have red snapper, shark, and then spider at the end. So let's take a look. So here you can see harp. This carp was replaced with harp. We have brass. Whoops. We have brass. And then instead of fly, we have the red snapper and the shark. And then we have the spider. But we can also use the insert function. So instead of changing a value, let's say we just wanted to add a value between, carp and brass or brass and fly, what we can use is we can use this built-in insert function that we give it basically the index at where we want it, and then we take this value and it will insert it into the list. So here you can see carp, brass, spinning. Spinning was placed at index 2, and so whatever was at index 2 gets pushed to the right. So here we have carp, brass, spinning will then be replaced with fly, and then casting would be at index 3, and so when we put spinning in here, fly would then be at index 3. So once again, it would be pushed to the right along with spider, and casting would be in the index 3, the 4th place. We can also use the append function, which basically says instead of inserting it somewhere into the list, what we can do is we can put it at the end. So we only have carp, one value within our list. But let's say I wanted to add brass, red snapper, and shark. and I wanted to put them all at the end, what you can do is you can just use this append function, and it puts it all one after another. So you can see I have carp, and then I append brass to it first, and then I append red snapper to it, and then I append shark at the very end. Next I have the extend method. So what this does is I have this list here. My fish list is carp, brass, red snapper, and my lure list, which is fly, spider, and worm. So what happens is my lure list dot extend reel. So basically what this does is this adds reel to this my lure list, and then my fish list dot extend adds my lure list to my fish list. So this should return carp, brass, red snapper, fly, spider, worm, and reel. But let's take a look. Right, so we have carp, brass, red snapper, fly, spider, worm, and then we have R-E-E-L. This is because this is a string. This is also, once again, a data collection that consists of characters. So when we added a string rather than a list, if we wanted to make it just a word reel, what we would do is we would extend with a list with a string inside of it. And what this would return is an actual word, or a string, sorry. But just this means that this data collection consists of characters, which would be added one by one. And then we have the remove function. So let's say I don't want this, I don't want this element within this list. You can just use the remove function and specify which element you want to remove. And now we only have brass and red snapper. Very similarly, there's the pop function, which instead of grabbing the element and removing it using the element's name, what you can do is you can use the index. So let's say I don't know what elements are here. They could be anything, like grass, tree, bird. They could be anything, any of these words. But I know which index I want to remove it at. I could specify it in here, but let's say that I don't want to remove a specific index. I could just take the last index, and that would be with no argument. By default, the pop keyword removes the last element. So this statement would actually remove red snapper, and this statement, since it specifies at index 1, this would remove the brass element. So here you can see I popped element 1, which means brass got rid of, and then when I print my fish statement, I have carp, and then I have red snapper. And then here I print my fish list, and here you can see I removed both brass and I removed red snapper, so all I have left is carp. The clear function removes all the elements within a list, making it empty. So here you can see I have 1, 2, 3 elements, but then I use the clear function and my lure list is now empty. And then the sort function, similar to integers, what this does is this sorts elements of strings based in alphabetical order. So first you're going to get arowana because the first letter of the first string is A, so it will go in front. And then we have brass go second. It won't go anywhere. It'll stay in this position because it's B. And then we have CA and CA, and then it keeps going down for every letter. And A, B, C, D, E, F, G, H, I, J, K, L, N, O, P, Q, R, S, T. So R goes before T, which means that carp will be here in the index 2, the third statement, and then catfish, and then shark. But let's take a look. Yep, here you can see arowana, brass, carp, catfish, red snapper, shark. And once again, what you can do is you can say reverse is equal to true. So if you want it to go in reverse alphabetical order, Here you can see shark, red snapper, catfish, carp, brass, arowana. So you can sort it backwards or forwards. And then you can join two lists by using the addition operator. Here we have my fish list, carp, brass, salmon, red snapper, and then we have insect list, fly, beetle, ant, and dragonfly. And when we add these two lists, first it'll be my fish list, and then it will be my insect list. So after red snapper, we should see fly, beetle, ant, and dragonfly. And indeed we do. Carp, brass, salmon, red snapper, fly, beetle, ant, and dragonfly. We can also multiply lists, same as we can multiply strings. If we wanted to basically have carp, brass, salmon, red snapper, carp, brass, salmon, red snapper, what we could do is we could just multiply this twice, and here you can see carp, brass, salmon, red snapper, that's the first one, and then carp, brass, salmon, red snapper, that's the second one. We can also just delete an entire list, similar to how we can delete variables. We just say delete my variable. But if we were to access this, then once again you'll see that we get an error because we are attempting to access a value that has already been deleted. Here you can see name my fish list is not defined. So next we have tuples. So a lot of these data collections are going to be very similar to one another. Here though, you can see that my empty tuple, they use parentheses instead of square brackets. You may notice though that when you try to get the type of my empty tuple, or you print out my empty tuple, you'll see that this is just a parentheses and the class is tuple. You can also create a tuple using the constructor. So here you have the keyword tuple, and then you try to print empty tuple, you will get a set of parentheses, and then the type will be class tuple. You can create a tuple with one element, however, you want to make sure that you do use the parentheses, because if you just did this, what you would really get is a value of integer, because Python will recognize these parentheses as operations of precedence, which means it will just try to, do this first, even though there's nothing else. You want to make sure you have a comma here to make sure you basically tell Python, hey, this is a tuple and not just an integer with parentheses around it. And then if we press the run button, you can see it recognizes, okay, this is actually a tuple, not just an integer. But you don't actually need parentheses, so you can have a tuple with multiple values, and you can even have duplicate values within your tuple. So here you can see when we print it out, we have the class tuple, and we have 1, 2, 3, and 3. We can unpack tuples by assigning an element to each. We can assign a variable to each element within the tuple. So here you can see my first element would be equal to carp, my second element would be equal to anaconda, and my third element would be equal to shark. And if we print each of them, you'll see we have carp, anaconda, and shark. We can also use a tuple constructor, which basically says that I assign my variable to be equal to a tuple that is of these two elements. And here you can see we have a tuple of wolf and rabbit. And just like lists, tuples also have indexes. So we have kangaroo at index 0, quokka at 1, and bandicoot at 2. And we can also access at index 2, and you'll see that we receive bandicoot. And we can also access, sections of our tuple. And here you can see we have also all the kinds of data types. Just like lists, we can include integers, floats, complex values, strings, booleans, and even other tuples, and other lists as well. So here, if we grab every value to 5, we are at index 0, 1, 2, 3, 4, 5, but it would not include 5, so we would just get all of these values, and then -3 to -1 would be -1, -2, -3. It would just be Python true, and then this tuple here. And that is indeed the case. And then we have the count function, which basically returns how many times this element is repeated within a tuple. So you can see it's repeated 1, 2, 3, 4, 5, 6 times, so it would return the value of 6. And then we have the index function, which basically says, okay, where, at what point within this tuple, what is the index of a given element? So here you can see I have index 4. So it will find the element of 4, and then it will return an index, which should be 3. Once again, this is because, indexes always start at 0. So at 1, the index is 0. At 2, the index is 1. At 3, the index is 2. And at 4, the index is 3. This is why it returns the value of 3. However, so tuples are very similar to lists, but the biggest difference between tuples and lists is that tuples are immutable. And so what this means is that you can't use any of these basic operations within tuples. You can't change individual elements within a tuple. You can only change the tuple itself or retrieve all the values from it. So you can't append anything. You can't basically insert the value of 10 at the end. You can't insert a value of 10 at 0. You can't delete elements of a tuple. And you cannot change the values and replace them with different ones. So you can see line 294 gives an error. Line 295 gives an error. Line 296 gives an error. And line 297 gives an error. So all of these statements will not work on tuples. What we can do is we can print the length of it. So we can see that we do have 9 values within our tuple, so that's why we receive a 9 after we get the length of it. And we can also use the sorted function. So once again, if we have values, range of values that are, greater or less than, then we can use the sorted function. And we can see that it starts at -7 and goes all the way up to 12. And once again, you can use the reverse function to make it so that it goes from greater to less rather than less to greater. We can also join two tuples. So we have my fish tuple, pike, bass, carp, my mammal tuple, blue whale, orca, dolphin. And let's say that I just wanted to make one big tuple that contains these values and these values. You can just use the addition operator for this. And when we print my animal tuple, you can see that we have all the elements of both tuples within one. And very similarly to lists, you can also multiply tuples to each other and you will get repetition of elements. Here we have pike, bass, carp, pike, bass, carp. And we can also use membership operators. So if I were to check to see if a string existed within a tuple, I would just say print this value is in my fish tuple. And since it is, it should return a true value, which it does. And then we can also just delete the entire tuple, which means that this variable just would not exist anymore and all its values are gone. Okay, so next we have dictionaries. So dictionaries are created with curly braces. So we've had square braces, we have parentheses, and now we have curly braces. So this does return a dictionary. And here we should type print type my empty dict. This would return a dictionary. But there's also a constructor for it, which is the dict keyword, and when we print an empty dict, it should give us just a set of curly braces. So, okay, let's add something to this dictionary. This data collection actually consists of keys and values. So instead of it just being one data after another. There's two types of data that exist at each index. So let me show you. Here we have my test dictionary, which is an empty dictionary, and then we say in my test dictionary at this key we would have this value, and at this key we would have this value, and at this key we would have this value. So what would this look like? Let's take a look. Here we have at name we would have Jacob, at age we would have 21, and at sex we would have male. So you can see that at each index we have a colon that separates this key value from the actual value of the key. So here I've given a little bit of a demonstration as to how this dictionary would look like. We have my first dictionary, which has an occupation key, and inside that occupation key we have a tuple of student and programmer, and then we have the next index of the dictionary, which is 1, would be name, has a name key, and then a Jacob value associated to that name key. And then at index 2, the next element of the dictionary, we have age, which is a key, and then another tuple, which is the value of the age key. So here, for instance, if we say print my first dictionary, age at 1. So instead of accessing a dictionary by index, what you can do is you can say, I want this key value. So what is the value of this key? When you give it age, it will return the tuple that is associated with age. So in here we have 72, 32, and 21. And then we have another square bracket index because we want to grab the value of 32, which would be index 1 of this tuple. We can also use the values keyword, which instead of checking for the keys, we can use the values. So I have a list of my dictionary values, which means this would just be a list of a tuple first with student programmer, and then a string in the second element, in the second element of this list with Jacob, and then a tuple once again in the third element of this list. So, but we want to grab the first index of this list, which would be student and programmer, and then I would want to grab the value at index 1 of this tuple, which would then return programmer. So let's take a look. We do indeed get programmer. We can also use the dictionary constructor. So let's say I'm just going to make a very simple dictionary with 3 keys. I would have a dict with occupation as 1 key, name as another key, and age as a 3rd key. And then for each one, just give it a simple value. When we print it out, here you can see we have our key and we have our value. So that's how you would do it with a dictionary constructor. Then we have the length function. So if you remember here, you can see the index of the dictionary. Each key and value within a dictionary is 1 index. So the length that we're really looking for is there's 1 index here, there's a second index here, and there's a third index here. So the length of this dictionary would be 3, which indeed it is. So let's try to get the value of a key. Here I have the dict constructor once again with a name keyword, age keyword, and occupation keyword, and then I want to grab the value of the age after the dictionary is completed. So once this dictionary is created, we would have something very similar to this, actually, this statement right here. But age would be 21, and since we are trying to access the key within the dictionary of age, it should return 21, which indeed it does. Now, you can also have a nested dictionary. So you might have noticed here we have a tuple within a dictionary. You can also have lists, and you can have other dictionaries within a dictionary. So here my dictionary, planets, has the key of a whole dictionary that consists of key values of integers with their value associated to be strings. So 1 would be Mercury, 2 would be Venus, and then 3 would be another dictionary that contains a single key value of A with a value of a tuple of Earth and Mars. So when we print this out, we have 1 dictionary, 2 dictionaries, 3 dictionaries, all in one statement. So let's say I wanted to grab the planets key within the dictionary. Well, we would get all of this because this one dictionary only has one key with its value being another dictionary. Okay, so what if I wanted to grab the key 1? Well, this would return Mercury. This would just return a simple string of Mercury. But okay, so what if I wanted to grab, let's say, Earth, for instance? What you would have to do is you would have to create first the index of planets, which would return this whole statement, then the index of 3, which would return this dictionary, and then you would have to use the index of A because you want to get the value of, the key of A to get its values, and then you would want to use the value of 0 if you wanted to get Earth, or 1 if you wanted to get Mars, because this is a tuple and it has its own index. So here you can see we got Earth, but if I want to get Mars, I would just replace this with 1, and I would get Mars. Let's see what happens when I run this statement. So here I have my dictionary planets 3, A, 1, 1 to 3. What happens here is that this statement will get me Mars, just like this previous statement did. But since Mars is a string, I can also do one final index to get just the value of A and R within Mars, since this index would return the value of AR. A would be the value of index 1, and R would be the value of index 2. And even though it goes to index 3, S is not included within indexing. Now we also have the get function, which is very similar to the function here, which is just using an index. The get function is basically the same as saying I want to put some square brackets around this key, give me its value. And indeed, you can see I have 25 here, but the same thing happens when we use the get statement. So what we get is 25. So we can actually get the keys instead of the values for the entire dictionary using the keys keyword. And here you can see it gives us a list of occupation, name, and age. And then we can do the opposite. We can just grab the values from the dictionary. So in this case, it would return student, Kirill, and 25. And then if we want to grab both, what we can do is we can use the items function. And in this case, it gives us a list of tuples, and where each index of the dictionary has a tuple with the first statement of that tuple being the key and the second statement being the value of that key. Then we have the update function. So this is used to basically say, okay, this value is not going to be, the value of this key is not going to be 21 anymore. We're actually going to change it to 33, for instance. Here you can see after the update statement, I've changed my age to 33 rather than 21. So occupation student, name Jacob, age 33. And very similar to both a list and a tuple, we have access to the pop function. So let's say I want to pop the key name. Here I would just get occupation student, age 21. And then if I were to give no value here, then it would just pop the age instead, which is the last value within the dictionary. And for a dictionary, you actually have to provide the key because it will actually not pop at the end of the dictionary. You can also delete an item. So here, let's say I have no need for this key anymore. We can just completely delete it, and it'll be gone forever. And then we can just delete an entire dictionary, so this dictionary will not exist after using the del keyword. And then the last data collection is sets. So a set also uses curly braces, which may be a little bit confusing, but if we try to create the type of this, we will see that we actually have a dict, not a set. So how do we change this? Well, very similar to tuples. If we would need to add a single value, and then this should return a set. Here you can see now we have created this class to be a set. We can also use the set constructor. So here we have my empty set would just be set, and then we have the class as set. So here we can create a set with multiple string values. So very similar to tuples or lists. We have red snapper, pike, perch, salmon, bass, carp. This is interesting. So there is no order within sets. You'll notice that even though I started with carp and ended with perch, here when I print my set, I have red snapper in the front and carp in the back. So the thing with sets is that they don't have an order. Each position is random, and sets are actually immutable. So you cannot append values. You cannot update values or delete values within a set. But you can also use the set constructor. So here, if we use print myFishSet, you can see we also have all the values within our set. And if we attempt to create a set with duplicates, you'll notice that we only have one bass value. Even though we have 1, 2, 3 when we declared the values of our fish set, there's only one when we print it. This is because sets cannot contain duplicates. Actually, we had 4, not 3. And then we can also use Boolean values and integers within our sets as well. But if you notice, the value of 1 is gone because when you cast the value of true to an integer, it actually, the value of 1 to Boolean, you will get the value of true. This is why sets will get rid of the value of 1 if there is a true statement, and 0 if there is a false statement within the set. So we can add values to the set, but we can't give it a defined index. We can't say put it at the end or put it at the beginning or somewhere in the middle. We can't say exactly where we want to put it. Instead, we just add it to what's basically a bag of M&Ms. You don't know which one is going to be in what order. So here we have the update function, which basically says that my second list is my second set, which is a set of red snapper and salmon, will update with my first set with carp and bass. So if I print my first set, then you'll see that it has added this set to this set. Now we also have the remove function. So let's say I know not the index of an element, but the exact value of an element. Then I can remove and take that element out of the set. So here you can see I have bass, red snapper, and salmon, but it does not include carp because we removed it. Next we have the discard function. So we have my first set is equal to carp, bass, red snapper, and salmon. And I basically just wanted to get rid of red snapper. So you can see that this sounds very similar to the remove function, but the biggest difference here is that when you discard it, the order gets jumbled. So here you can see salmon, bass, and carp. Even though we have carp, bass, red snapper, salmon, we removed red snapper, so the order should have been carp, bass, and salmon. This order becomes jumbled. This is different from the remove function, where when we remove carp, the order remains the same, so we would still have bass, red snapper, and salmon. Here, the order gets jumbled. Now here we can use the pop function, which basically just takes a random value from the first set. So here you can see bass, salmon, carp, even though salmon was at the end of the data set. Because we popped because it's a set, it's basically any random order. There is no index, so when we popped, we just popped a random value. And in this case, it was red snapper. And then finally, we have the clear function, which basically just gets rid of everything in the set, so it becomes an empty set. And then we have the intersection function. So what happens here is that if we have any similar values, then you'll see with carp and red snapper, we only include those values that intersect. And then the symmetric difference update function, and it's quite a mouthful, I know, actually does the opposite. So basically this says, okay, if these values are the same, then we don't include them, and we only include the values that are different. So here, you can see we have carp and bass, because carp and bass were the only values that were different within the second set. And then we have the union function, which basically just takes two sets and then combines them. So here you can see we have red snapper, salmon, and carp and bass. And then we can also take the length of the second set, which just counts how many elements are within our set. Which in this case, we actually have 4. This is because bass and bass are very similar, or not very similar, they're the same value. It gets rid of the duplicate values first, and then the set becomes random, jumbles in the order, and then we would have carp, red snapper, salmon, bass, which is why we only have 4 elements within our set. And then we can also delete a set, which means it will be completely gone. So this was data collections. This was kind of a long video, and this was a bit tedious, but hopefully you've been following along. Thank you so much for watching, and I will see you in the next Python Basics tutorial.